Hey everybody, thank you for attending today's webinar. Today we're going to be covering exponents and roots. As always, I'll begin the webinar for a little bit and then Scott will jump in and give you some more questions. But before we get started, two quick announcements and one story I wanted to share with everyone because I know everyone's kind of knee-deep in studying for the GMAT at the moment. But the first announcement, or two announcements, I mentioned this last week, but we do have a YouTube channel up now, which we'll paste the link in the chat box. The YouTube channel essentially is going to house all of our webinar videos, so you guys have the opportunity to rewatch them and practice in addition to doing your normal study routine. And then secondly, we recently put up a blog where we've been working through and posting official guide solutions. And the official guide is a great book. It's not the best book to learn from specifically, but it's a fantastic source for review. And as most of you know, sometimes the solutions, although they're correct, are not the most efficient. And so Scott and I have spent a lot of time putting out what we feel are the best way to solve those questions. So if you get into those and you're stumped and you want a better solution than what you're seeing in the book, go to our blog. Right now we have probably 80% of the problem-solving questions up, and we will be working on data sufficiency shortly. The last note I wanted to mention is some pretty exciting news actually for target test prep. We had two separate students get 740s last week with very high math scores. One was a 47, one was a 49. And one of the students, she kind of from start to finish has a pretty motivational story that I think is very relatable to everyone here at this webinar. And, I myself was a student at one time, and I know how frustrating and challenging it is to deal with the GMAT and how sometimes things don't work out the way you want them to the first time around. And for this particular student, she literally, in her first ever GMAT attempt, after taking a full prep course and studying for a decent amount of time, was so flustered by her first GMAT that she actually walked out of the exam. She didn't take the whole exam and cancel her score. She literally got up and walked out. It went so poorly for her. She found us about 4 months ago, explained the situation to me, and purchased and used our materials. And she ended up working very hard, followed our study plan, did everything from A to Z, truly understood the content, and she walked in last week and got a 740, 49 in the quant. And one of the things she said to me really resonated was the confidence she felt on the exam. She said by question 5, she had known she had gotten the first 4 right, and she felt like she just had this test. And for all of you out there who are studying and are trying to hit, June deadlines or July deadlines, remember, confidence is almost half the battle when it comes to this test. And, if whatever you're doing is not giving you the confidence to say, no matter what they put in front of me, I'll have the opportunity to solve that question, then look at what you're doing, how you're studying, what you're using, and you're going to find that this stuff is learnable, and you can beat this test, and you can be very successful. And if you're having troubles and you feel like it's a long path, just stay focused and move forward. Remember, guys, it's only May right now. First round deadlines aren't until about September. Second round deadlines aren't until about, December, January. So you have plenty of time. Just make sure everything you're doing is, extremely impactful in your studying. So hopefully that was a breath of fresh air for most of you. And what I want to do is I want to get into, I'm going to start with some roots today, and then we're going to move into some exponents, and I'm sure Scott has some fairly challenging stuff for everyone. First thing I want to talk about is approximation with roots. And, one of the things that the GMAT kind of expects you to know is not to be able to memorize all roots, imperfect roots that is, but there are 3 main ones that they really do like to test you on and throw out there, especially because 2 of the 3 are very relevant to things that you'll see in geometry. But root 2, root 3, root 5, these are the ones you want to have kind of memorized as approximates. And that way, if you see them, you'll know right away that, root 2 is approximately 1.4, root 3 is approximately 1.7, and root 5 is approximately root 2.2. And that way, you're not going to have to go the longer route of actually figuring out what the values are of these, and you'll be able to answer questions pretty efficiently when you see them. So with that said, I want to throw a question at everyone, which is going to take these roots and force you to do a little bit of approximation, and then we'll get into some that are slightly more challenging. So let's start with this here. Give everyone about 2 minutes. As always, put your answer into the public chat box so we can see what everyone is getting for answers. Okay, so that was about 2 minutes. I see a lot of people are putting answers down. So the question is asking which of the following expressions, meaning the answer choices, is the largest. Now, the one thing we'll notice is that we have some imperfect roots here. Square root of 2, square root of 3, square root of 5, square root of 7, square root of 11. And luckily, the first 3 answer choices, A, B, and C, we just went through the memorizations of. So we know root 2 is 1.4, so the approximate value of this is going to be 9.4. We know that root 3 is 1.7, so the approximation here is going to be 8.7. So we see A is still bigger than B. Root 5, we have 2.2. We're adding 6 to that. That's giving us 8.2. And then there's a few more here. We have root 7 and root 5. So this is where we can kind of practice how to estimate these values, root 7 and root 11, if we don't actually have them memorized. And the reality is you don't have to have those memorized, because they could throw any number under that root sign if they wanted to. So what you do is you take the square root of 7. If you want, you can make a mock number lineup. It doesn't matter, or you can just write it out. But let's say we have root 7 here. The goal is to figure out the perfect root above it and the perfect root below it. So we see that root 9 is the perfect root above, and that equals 3. We see that the perfect root below root 7 is square root of 4. That equals 2. We notice that 7 is a little closer to 9 than 4. It's 3 units away from 4. It's 2 units away from 9, which means it's closer to 9, or in other words, the square root of 7 is closer to the square root of 9 than it is to the square root of 4. So what we can say is the square root of 7 is about, let's say, 2.6, because it's closer to 9. So then we say, okay, we have 2.6 plus 5. That gives us 7.6. Now, we can do something similar. The square root of 11, I'll do that in green towards the bottom. Put the square root of 11 here. We say the perfect square root below it is the square root of 9. Perfect square root above it is the square root of 16. Once again, notice the distance, right? 11 is closer to 9. Square root of 9 is 3. Square root of 16 is 4. So the square root of 11 is closer to the square root of 9. So we can say it's about, let's say, 3.2. So to finish this up, we have 3.2 plus 4. That's going to give us 7.2, and we see that our answer is answer choice A. You know, if you were short on time here, it starts to become pretty obvious that you're not going to get a value that's bigger than 9.4, especially when you see that you're adding 8 to root 2, and we know that there's no other values in our answer choices that are going to be closer to 8, especially under the square root sign, because the square root of 64 is actually equal to 8, and notice we have nothing close to that here. But if you do have the time, it never hurts to be able to quickly do these out. Obviously, the faster and more efficiently that you can approximate these, the quicker a question like this will go. So what I want to do next is I want to do a little bit more of a more challenging approximation question. And in this question, we are going to be in a situation where we are actually approximating not just square roots, but also cubed roots, and you'll see also fourth roots. So let me put that up, and I'll give everyone about 2 minutes once again, and then we'll go through it. Okay, so that was about 2 minutes there. This question is probably going to seem harder for some of you just because of the cubed roots and the fourth roots, but true to form, and Scott says this all the time, you're always looking for patterns on the GMAT. You're always looking for ways to do things simpler. I like to use the word systematic. You always want a system in place. You want to feel like your brain is on easy street half the time when you're doing GMAT questions. So the point of what I'm saying is that if you can approximate a square root, why not be able to approximate a cubed root? Why not be able to approximate a fourth root, a fifth root, a sixth root? And that's exactly what we have going on here. Now, luckily, the first term in our set of terms, root 9 plus cubed root of 9 plus fourth root of 9, well, this is just going to be 3, because obviously the square root of 9 is 3. So where the confusion may start is when you have the cubed root of 9. Now, once again, we stick cubed root of 9 on our little number line here, and we say, all right, what is the cubed root below 9 and the cubed root above 9? Perfect cubed root below, perfect cubed root above, meaning it comes out to equal an integer. So we should have memorized that the cubed root of 8 is 2, and that the cubed root of 27 is 3. So there are the perfect cube roots below square root of 9 and above square root of 9. So that, looking at the distance between 9 and 8 and 9 and 27, we clearly see that cube root of 9 is about 2.1 because it's pretty much right on top of cube root of 8, and it's pretty far away from cube root of 27. Now, the nice thing about questions like this, if you're in a rush or in a hurry, well, we know that 3 plus 2.1 is 5.1, so we automatically get to eliminate A. And the reality is we know that the smallest perfect root is definitely 1 because the square root of 1, cube root of 1, fourth root of 1, fifth root of 1, they're all equal to 1. So at a bare minimum, we know the sum of these three terms is going to be 6.1 or higher because 3 plus 2.1 plus 1 is 6.1. So it means that we have the opportunity to eliminate B and C. Now again, the way I go about things is I don't necessarily do that if I have the time, but if you're running out of time and you have to make a guess very quickly and move on, this is at least one way to increase your odds. So finally, we'll change the color here and do it in blue. We'll do the fourth root of 9. We'll stick that on our number line. And we know that the perfect root below that, perfect fourth root that is actually the fourth root of 1, which gives us 1. And the perfect root above it is the fourth root 16, that gives us 2. You'll notice that 9 is it's pretty much in the middle of 16 and 1. It's slightly closer to 16. So we'll say it's about, again, we'll say it's a little bit bigger. We'll say it's about 1.2 here because that's going to make it a little closer to 2 than it is to 1. So now we add these up. We get 3 plus 2.1 plus 1.2, and we see that the answer is between 6 and 7, so it's D. So hopefully, if this was a struggle for some of you, my suggestion is throw this on a flashcard, know how to do these approximations, and life is going to become a lot easier. So let's move on to doing some quadratic equations. So one of the things that's interesting about, or excuse me, not quadratic equations, well actually quadratic equations and exponents. And one of the interesting thing about exponents is that quadratic equations can become a part of what you're doing within exponents. And the best part about it is that your process doesn't really change in terms of your rules. Your exponent rules don't change, and your quadratic rules don't change. And so this is kind of cool. And I know some people, they'll get to this and they struggle with it, but if you can kind of take what you know from the quadratics chapter what you know from the exponents chapter and put it together, you're going to find that we're not asking you, or the GMAT is not asking you to do anything different than you're actually used to. So let's try one that I feel is fairly basic, and then we're going to move on to some more challenging ones after that. Okay, so that was about 2 minutes. This one wasn't, as I said, that bad. Want to try to get through this and one more challenging one. So one of the things that you've all learned from our curriculum, you've also learned from our past webinars, is that when you have exponents and they're equal to each other, you have your bases that are equal, you get the opportunity to drop the bases and solve for just the exponents. So what we have here is x plus y all squared equals x minus y all squared. So this is testing us on some of your quadratic principles or the quadratic identities. So for those that have these memorized, we have this equaling minus 2xy plus y squared, and then we can start canceling. So x squareds are gone, y squareds are gone. We can bring this over, gives us 4xy equals 0, or xy equals 0. Now, I want to do one more quadratic question. This is going to be testing us on actually a quadratic expression. And there's going to be a few different principles involved, but kind of the same idea, same principles that you know from quadratics, your quadratic identities, etc., are going to come into play here. So I'll give everyone roughly 2 minutes, and then we can chat about the result. Okay, so let's talk about this guy here. And for some of you, again, this might be a little more challenging than the ones we were doing before. The one thing that really throws students off on this question is they always want to drop the bases and just deal with the exponents. But to be clear, if you have an expression, you can't drop the bases. It's not allowed because it's not equaling anything. If you have an equation where you have something on one side of the equal sign and something on the other side of the equal sign, then you get to make your bases the same, and when they're the same, drop them. Because this is an expression, you do not drop your bases. You will end up with one base. So with that said, we're going to use some quadratic rules. We are going to say 3 to the a squared plus b squared plus 2ab. And you'll notice that we have a 3 to the b squared on the bottom. And remember, the rules of exponents, you see on the top right, say this. So we're going to very quickly say that this is a minus b squared. The other thing that's useful is taking the 9 to the minus ab and prime factorizing that. Of course, 9 is the equivalent of 3 squared. So you have 3 to the minus 2ab. Now again, one other exponent rule here is x to the a times x to the b is x to the a plus b. So when this is all said and done, we have 3 to the a squared plus b squared plus 2ab minus b squared minus 2ab. And lo and behold, we get some canceling, and we have 3 to the a squared, which is 243. So this was a pretty good review of how to deal with quadratics and exponents, a pretty good review of how to deal with approximation, with roots, and a lot of the stuff we covered today. You know, if you have a few key components memorized, life is not that bad when you see these questions. Sure, do they look scary and hard? Of course, but that's the game of the GMAT. As you get confident, as you know these things, you'll be able to easily knock these pretty high-level questions out of the park. So with that said, I'm going to toss things over to Scott. He, I'm sure, is going to challenge the heck out of everyone and go from there. So Scott, you can jump in.
Hey, Jeff, thanks a lot. How's the audio?
It's good.
Okay, great, thanks. Hey, everybody, good morning. Thanks so much for coming. As always, I'm sure you had better stuff you could do, so we're here. We're pleased that you're here with us. So yeah, Jeff just gave you a really great overview of a bunch of really high value stuff. And if you pay close attention, the skills he gave you are going to serve you well. And I'm just going to piggyback on a lot of these. And, you know, I say this every time, but I truly mean it. I can't say it enough. You got to strive for simplicity, right? And I'll say it in every webinar you come to. If you make things more complex, your life is going to be difficult. Right? All GMAT questions give you the opportunity to make things more complex, and should you do that, you're going to have a tough road to walk or to drive or whatever you want to do. Your goal is to find the simplicity within the complexity, and part of that starts with thinking about it through the lens of children's eyes, thinking about it as a child would. You know, adults love to overcomplicate everything because we have more knowledge and more experience, but if you've ever seen a little kid solve math problems, there's an innocence about what they're doing because they're not jaded by anything. They're just applying some rules that they know, and they're actually thinking too. And when you see these questions, guys, I want you to ask yourself, how can I simplify this? Like, what's the easiest route to take, and how can I protect myself against overcomplicating these things? And keep that in mind. So with that said, we're going to do some reasonably complex stuff, but still stuff that's very fundamental and critical to understand. So let's start with this guy. We'll shoot for somewhere between 2 and 3 minutes. And as you have your answers, you can put them in the chat box. And this will be interesting to see the distribution of answers on this guy. So let's take it away. All right, guys, just a little over 2 minutes. So, as expected, we have kind of a range of answers here. And this problem has something really important. So some of you, I'm sure, did the following. So it says if x and z are positive constants, for how many values of y is x times y squared equal to z times y to the fourth, right? So for how many values? A lot of you, if not most of you, probably canceled off as follows. You knocked off a y squared, y squared and y squared over here, and you said x is equal to z times y squared. Now, if you did that, you made a common mistake which violated an important rule of math. Now, the reason you can't do that is you don't know anything about y. And in math, we don't believe in crossing off variables across an equal sign when we don't know whether that variable could be 0. Now, when engineers at Boeing Aircraft do that, they don't do this, but if they did, planes would crash because mathematical models would not represent reality properly. And when we do it on the GMAT, we fall right into traps that are nicely laid for us. Because of course, it's so seductive, let's cross off the y squared with a y to the fourth. And again, from past lessons, remember, it gets down to type 1 versus type 2 thinking. Type 1 says, sure, let's knock off the y squared. Perfect. Type 2 says, wait a minute, what's the problem there? So, of course, the problem is that, y could be 0 here. So anytime you don't know whether a variable could be 0, you're not allowed to cross it off from the equation. So this won't work. And if you did that, take a big note of y. So instead, what we have to do is solve this as the quadratic equation that it is. What we'll do here, of course, is we'll bring all of the terms to one side of the equation, and we'll set it equal to 0. Now, if you guys have been coming to the webinars or using our material, you know right away, instinctually, you're going to factor out that greatest common factor. That's the smooth road, and you'll be left with x minus z y squared inside the parentheses. At this point, many of you who are using our stuff know that you have to apply the zero product rule, which is a fancy name for a really simple concept, which says that if a times b is equal to 0, well, either a must be equal to 0, or b must be equal to 0, or both are equal to 0. And we're going to apply this rule here. This is called the zero product rule or zero product principle, whatever you want to call it. So what we're going to say here is, well, either y squared must be 0 or x minus z y squared must be 0. Right? And that makes our life easy. And here right away, we can see, well, if y squared is equal to 0, then y must be 0. And right away, you now see the problem with canceling off the y across both sides of the equal sign, because lo and behold, one of the solutions to the equation is, well, y could be equal to 0. And anytime you sort of deliberately say to yourself, well, there's no chance of y being 0, and you cross him off from both sides of the equation, you miss that solution. Okay, so y could be 0. Now, the second part here is a little bit challenging for students, but it's not hard. Just watch carefully. So we're going to have to solve this for y, right? So what we can do here is just and we'll say y squared equal to x over. We probably do is move the x to the right-hand side of the equation and then divide by z. Okay. a variable, so we're going to have this plus or minus positive constants, and that means by definition they don't change. They're the same numbers each time. So what that means is that we're going to have 3 total solutions. 3 total solutions. We having audio problems here, guys? Let's see. You guys having a hard time hearing me?
It's better now, Scott.
Oh, okay.
But it was a little choppy for a second.
Okay, but we're back now?
Yeah, we're back. Everyone, if it happens again, just shoot a note.
Yeah, thanks a lot, guys. Sorry about that. Right. So what we have here, guys, is 3 solutions, right? Because you have the y equals 0 solution. Okay, you have y could be equal to 0, or you could have y is equal to plus or minus the square root of x over z. Right, so what that means is there are a total of 3 values of y that will make this equation true. Okay, so some of you missed that. Let me say it again, because this is an important one, just to make sure that we're all on the same page here. So let me back up a few steps to where some of you said you missed. So let's back up to right here. Okay. So what I had said was that if you have x minus zy squared is equal to 0, then y squared is equal to x divided by z, right? Now, to solve that, what you have to do is you have to take the square root of both sides of the equation. Okay, so you'll say y is equal to plus or minus the square root of x over z. And of course, we have to have the plus or minus here because we've unsquared a variable. And there could be a positive solution, and there could be a negative solution. Okay, and because x and z are positive constants, what it means is this is 2 solutions right here. 2 solutions, plus or minus square root of x over z. So when you add in the y could be 0, now you have a total of 3 solutions, or 3 values of y that will make this equation true. Now, that's usually pretty tough, at least for beginner students. But I encourage you to study that and not to be guilty of making that mistake of crossing the y squared across both sides of the equation, of course, because you now know you don't know what the value of y is. You don't know what the value of y is. Okay, take that down, and we're going to load up another question. Okay, let's give this a whirl. And we'll shoot for about 2 minutes starting now. Okay, guys, let's give this a whirl. So we know that x is greater than 0, and we know that x to the 30th is equal to 75. We want to know what's the value of x to the 15th. Well, the key pattern I want you guys to see here is we're going from x to the 30th to x to the 15th. Notice we're cutting the exponent down by exactly half. Okay, and once you see that, that reminds us of the fact of that the square root of x is the same thing as x to the 1/2. So we have to ask ourselves the question, how do we get from x to the 30 to x to the 15th? Well, because the square root of x is equal to x to the 1/2, what that means is we do that by taking the square root of both sides, right? Because when we take the square root of x, we're saying cut the exponent down by 1/2 or multiply it by 1/2. So what we'll do here is we'll say we have x to the 30 is equal to 75, and we can take the square root of the left and the square root of the right. On the left, we're going to get x to the 15th. And we're going to get that's equal to, we'll break this down to the square root of 25 times the square root of 3. So x to the 15th is equal to 5 times the square root of 3. Okay, so that means we're looking at answer choice C here. So the key thing to see is that when we take the square root, we cut the exponent down by half. Now, remember guys, small pieces of data drastically can change the course of the problem here, right? Because we were told that x is greater than 0. Now, if we didn't know that x was greater than 0, which could be a very, common problem type, at that point, guys, as soon as we unsquare this x to the 30, we'd be coming up with x to the 15th is equal to, and then the answer would be plus or minus 5 rad 3. Right? Because remember, when you unsquare an even exponent, you're going to have two solutions, the plus solution and the minus solution. So if you know that x is greater than 0, well, then there's no negative solution. But if you're not told that x is greater than 0, you have to account for the plus or minus solution. And that's no different from saying the following, right? If I say, x squared is equal to 16, what's the value of x? Well, many of you will correctly say that x is equal to plus or minus 4, right? And the reason why you're saying plus or minus 4 is you're realizing you're unsquaring an even exponent. And when you do that, you have to be cognizant of the fact that we're going to get two values. Okay, so be careful of that, and remember that the square root of x is the same thing as x to the 1/2 power. Really important. Okay, why don't you guys get any notes down you're going to take, and let's try another one. Okay, let's shoot for between 2 and 3 minutes on this guy. And we'll start now. Okay, guys, let's give this a whirl. Let's see how we all did on this guy. So the first thing I want you guys to see is, just realize that you're usually not given things to you in the form that are going to be most helpful. So for example, we have 7 to the x minus 7 to the x minus 1 is equal to 6 times 7 to the 6th power. Well, I want you guys to see that 7 raised to the x minus 1 is probably better expressed as 7 to the x multiplied by 7 to the minus 1. And the reason it's probably better expressed in that form is because when we express it in that form, what we see is there's a common term, right? So remember, here's one term on the left-hand side of the equation. Here's another term on the left-hand side of the equation. Those terms in this case are separated by the minus sign. So many of you know now very well that you must factor out these common terms, or in this case, this common term. So because 7 to the x exists in the terms on the left-hand side, we're going to pull him out, okay? So when we pull 7 to the x from 7 to the x, we're left with a 1. And when we pull 7 to the x from 7 to the x, we're left with a 1. And, of course, that leaves us with 7 to the minus 1 right there, 7 to the minus 1. And if you have a hard time seeing this, guys, what you can practice doing is pushing the 7 to the x back through and asking yourself whether you will get exactly what you had here on this line. And, of course, you have to get what you had there on that line. Right, so that's an important skill, and that will make you better at factoring. The right side is still the same. So now we can do the work inside of the parentheses. So that's 7 to the x, and we see here this is the same thing as 1 minus 1/7, right? Because 7 to the minus 1 is just 1 over 7, and that's 6 times 7 to the 6th. Well, that's 7 to the x, right? Remember, you'd have to make 1 7 over 7, because we need a common denominator to subtract. So this would just give us 6/7 in the parentheses, 7 to the 6th. From here, there's a lot of ways we can go. One way would be to multiply by 7 over 6. Right, and by multiplying by 7 over 6, what we're doing here is we're getting rid of the 6/7 on the left-hand side of the equation, and we're moving closer to isolating the 7 to the x. At this point, guys, we can cross off the 6's, so those guys can go away and simplify a bit for us. Then we see we have 7 to the x is 7 to the 6th times 7. So 7 to the x is equal to 7 to the 7. And because these bases are equal, the exponents must be equal. So we see here that x must be equal to 7. Now, there are a lot of steps I took in there. And if any of those steps confuse you or are not crystal clear, you can practice with all of these guys in the Roots and Exponents chapter. Many of these skills can be decomposed down into simpler problems. This guy just happened to be pretty high value because he forced us to use a lot of exponent skills that we need to know. But notice, guys, there's not a lot of crazy calculations in any of these problems. It's more a matter of recognizing when some rules can be applied and then actually applying those rules carefully. And sometimes, there's other ways to solve this problem, and if you solved it a different way and got the right answer, as long as it was efficient, that's fine too. But this is a pretty clean way of doing it. So remember, guys, simplicity, simplicity, simplicity. And if you didn't catch that first problem I did, and you feel like you want to, you can email me, and somehow maybe I can show you what to do with that first problem. Just I know some of you, we lost audio for a minute. Other than that, guys, I appreciate you coming here this morning. If you have any questions, send Jeff an email, send me an email. Please provide us with feedback because we're tailoring the lessons more and more to the people in the group. So if you could, take a minute and fill out the feedback form, and that'll help us to better serve you in weeks to come, which of course is our only goal for these webinars. And otherwise, we look forward to seeing you here, same time, same place next week. You guys have a great rest of the week, and good luck with your GMAT studying.